If you want to know what kind of shark that is, I got you. This right here is one of our 3 species of thresher shark. There's the big-eyed thresher shark, the pelagic thresher shark, and then this one is the common thresher shark, Alopius vulpinus. Common threshers can be distinguished from the other 2 species using morphological characteristics. The ones that I noticed here are that we have this extremely short snout. Commons have the shortest snout out of all 3 species. And also we have a very dark coloration with a sort of white blotchy underside. If you're interested in some of those other morphological differences, here's a nice summary chart for you to check out. Let me not delay any further from what I know everyone really wants to see, which is what thresher sharks are known for. They are able to use that really long upper caudal lobe of their tail as a bullwhip to stun and even kill their prey on impact, that they then go circle around and feed on after the fact. And they're able to get 3 to 5 prey items per strike, and that's an extremely efficient form of hunting. Their tail moves so incredibly fast through the water that a phenomenon known as cavitation occurs, where a small vacuum pocket is formed that then implodes and releases an incredible amount of energy, and that's what stuns and kills their prey. That sounds familiar? That's also what our friend the mantis shrimp is known for. As if that's not enough coolness, thresher sharks also belong to the same order of sharks that great whites and makos do, which is order lamniformes. And just like their cousins, the great white sharks, the mako sharks, the salmon sharks, the porbeagle sharks, these guys are also regional endotherms. Whereas most other fish are ectotherms, or cold-blooded as we like to call them, which means that their internal body temperature is completely dictated by the temperature of their environment. Our laminate sharks, which includes our thresher sharks, are able to maintain a certain part of their body at an elevated temperature compared to the water because of special heat-producing red muscle that they keep very tight to their core, which is insulated from the rest of the water. So as those muscles produce heat, that heat is conserved within them and it helps their metabolism. That's why these are some of the most highest performing sharks that we have. The makos are extremely fast swimmers. We have the threshers doing these crazy acrobatic things in the water. That is why. Tuna are another one of our regional endotherms, and that's what makes their meat so different from other fish meats, because it's that high performance red muscle. Below you have a simplified diagram of a great white shark vascular system that shows how they're able to maintain that elevated core temperature. Their capillaries are set up into structures that allow for countercurrent heat exchange, where the cold blood that's returning from their extremities doesn't just get a free pass to their core where it would instantaneously lower their body temperature. It actually has to run parallel to the capillaries that are leaving the core with the warm blood. So the cold blood that's returning is getting warmed by the warm blood that's leaving the core, and that heat stays at the core instead of just getting sucked out of the shark the second the blood leaves the core. There's so many things I could talk about threshers. I hope you learned something new, and feel free to follow for more.